This video introduction is going to cover the virtual lab on periodic trends, where we will analyze trends within groups and periods on the periodic table of elements. So the first thing you need to do is, based on information in class, information from your notes, information that you look up online to help supplement, answer these three pre-lab questions based on organization of the periodic table, periodicity, and groups of elements. Okay. Then in part one, we're going to collect some data using an interactive periodic table found at this link here at www.ptable.com, which you can see in the window over to the right. So first, we're going to select one of the groups, 1, 2, 16, or 17, and complete the following data table. And we're going to do just for the first 4 elements. So if I were to choose group 16, let's say, I would be choosing oxygen, sulfur, selenium, tellurium. Okay, and for each of those elements, I'm going to write the symbol. So for sulfur, I'd write S. Number of protons, I'd write 16, right? Electrons, also 16. Now, atomic radius, I'm going to just get from this row right here where the radius is. Then electronegativity, right here, and ionization energy here. Okay, so I'm going to do that for each of those 4 elements in the group. And I'm going to repeat this, but I'm going to choose one of the periods, 1 through 4. So either row 1, row 2, row 3, or row 4. And I'm going to write the data for main group elements only. So if you choose group 4, what you have to make sure you do is don't include this middle part here. So just group 1, group 2, and 13 through 18. Okay, so if I were to choose the third period, it would be sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. And I would repeat the same process. So if I were to choose magnesium, I would write the symbol, number of protons, number of electrons, and then just record the radius, the electronegativity, and the ionization energy. Okay. All right. So now that we have all that data, we have to do some analysis, okay, and use that to help us come to some conclusions about periodic trends. So the first thing we're going to do is look at effective nuclear charge, which is a term we use to describe how much of the nuclear charge, the charge from the nucleus, is experienced by particular electrons in an atom. The nuclear charge is the total positive charge in the nucleus. So for example, if we use carbon, the nuclear charge is positive 6 because carbon has 6 protons, right? It also has 6 electrons when it's neutral. Here's the electron configuration, 1s2, 2s2, 2p6 for those, 2p2 for those 6 electrons. 2 of the electrons are in the inner core in this inner core group 1, and 4 of the electrons are in the outer shell in group 2. You can see here, okay? What level do those valence electrons occupy? They occupy energy level 2. And then the effective nuclear charge is positive 4. So the thing we're trying to answer here is, how do we approximate this effective nuclear charge? So if we focus on the electron configuration for carbon, we see there are 4 electrons in the second level and 2 in the first level. Electrons in the second level are further away from the nucleus. So the 2 electrons in the first level, these inner core electrons, partially shield those outer valence electrons from some of the nuclear charge. So to approximate, we will assume each inner core electron shields 1 proton from the electrons in the outermost valence shell. So the effective nuclear charge then is calculated. So how do we get this positive 4? We take the number of inner core electrons and subtract it from the total nuclear charge, Z. So Z, the total nuclear charge for carbon, is positive 6. We subtract the inner core of electrons, 2, and we get an effective nuclear charge of positive 4. So we're going to repeat that same process using the same elements from data tables 1 and 2. So for these 4, that would be which group you chose. So remember, I chose group 16. So I would do this for oxygen, sulfur, selenium, and tellurium, I would calculate effective nuclear charge. And then in this bottom part of the table, you would do that for whichever period you chose. So I chose period 3, so sodium, magnesium, and then so on, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Okay, so you'll finish it for that period. Okay, now, once you know all of these effective nuclear charges, you're going to make some observations about what happens to the effective nuclear charge first as you move across a period, and then make a general statement on the trend in atomic radius, in ionization energy, and in electronegativity, using the data you recorded in the first 2 data tables, as well as what you now know about effective nuclear charge. Okay. Then we're going to look at the same thing going down a group, what happens to the energy levels, and then make a general statement on the atomic radius, ionization energy, and electronegativity. Okay. And that is it.